Okay, Assalamualaikum and a good day everyone. Thank you Luqman. So Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, I hope all of you have a good day today. So my topic for sharing today is machine learning in software engineering. So this is a sharing topic because my niche area is actually in machine learning. So I would like to just share with you on how maybe we can combine these two area of knowledge together, okay, and how the industry do it, okay. So in this sharing, I will share with you on the present situation, a sneak peek on how the machine learning works, okay, and the software engineering for machine learning, what are the current practices and the best practices with machine learning in software engineering. And this is based on the Microsoft case study that have been shared by the Microsoft research and the conclusion from this sharing session. Okay, so in the current situation, surprisingly, there are so far only a little of machine learning have impacted. Okay, so there is no until this date. Okay, there are a few only that are the studies on machine learning on the software engineering. However, currently there are small changes in this area, and perhaps we can see a more significant changes and more to come, more years to come, in the situation of emerging on the software engineering. And because there are one obstacle to take up to these exciting technologies in the software engineering is lack of awareness on how they might be applied. Okay, people because the industry also, they have the doubt on using this machine learning because a lot of complexities in machine learning itself, because software engineering is one industry that have matured enough. Okay, they have the standard, they have the stages. Okay, and the machine learning is keep on evolving, and there are still some issues on applying the machine learning in the software engineering area. Okay, so this is the sneak peek on how the machine learning workflow. Okay, so there are 9 stages usually what we do in the machine learning. First is the model requirement. So in the model requirement is where you identify what type of models that are appropriate for the given problem. Okay, in machine learning we have you can classify your models into supervised. We can also have the semi-supervised, and we have also the unsupervised. And these models can be used based on the problems that you want to solve, what are the output or what are the objective that you want to solve, what are the problems. And also this is also based on the given data. And once, okay, so the first stage and the second stage, which is the data collection, is actually side by side. Okay, once you identify what kind of model that you want to pursue, what kind of a model that, for example, you want to use the supervised model. Okay, and then you have we can go to further to that stage, which is the data collection. Okay, so in the data collection, we look for, this is where you look for the data set lah. Okay, so we can use the internal data set, the ones that you might be having in the organization or maybe in your research area. Okay, and you can also use the open source that is related to the study or related to the problem, and you can also collect your own data set, which is coming from the scratch. Okay, and then this data you have to identify also whether your data is nominal or continuous kind of data. So type of data also is important in to make sure that it fits to the model that you choose previously. Okay, next is on the data cleaning. Okay, so data cleaning is very useful in the pre-processing in any of the big data area. So in data cleaning is to remove the inaccurate or noisy records from the data sets. Okay, so if you skip the data cleaning, which means your data set is not valid to be used in the model, because the data itself is not clean lah. That you have the data duplicate. You might have data duplication. You might have the data missing. So these data need to be removed, or the values of the data need to be change to other values that fit to the model itself. And then next we have the data labeling. That data labeling is in assigning the ground truth label to the to each record. So this is important so that you can evaluate, or you can train and evaluate your model later to check back, okay, to cross check whether what you train your data, your proposed model is correct or not. Okay, and then some of the model, okay, they have the data. Okay, next is feature engineering and the model training. Some of the model do not explicitly do this. Some of the model do. Okay, what we do in the data in the feature engineering, it is also known as sometimes as feature selection, whereby you select or you extract the informative features for your machine learning models. Okay, one of the downside of the machine learning models, okay, given that you have lots of the parameters in your data set, if you want to use all of these parameters, okay, into the model, you do not, okay, because this model, you have to remember, these are trained by the computer, kan, by the robot, by the computer lah, the models that you propose. Okay, so there is no human intervention in that. So in order to, if you want to fit all of these features, the model might think that all of these features are important, and this, okay, the downside of it, it will produce in the overfitting of your model, or your model will be too generalized, which means your model will be produced, we can say that it will be too good to be true. Okay, so if the model is too good to be true, means that there is something wrong in the features that you use. So that is why we highly suggest to have this feature engineering stage in the machine learning workflow, so that you can extract and select the most informative features for your machine learning model. And next, then you can start with the model training. So based on the models, okay, on the selected features that you have chosen, you will train and tune, okay, your data. This data is based on the clean data already. It's not from the raw, it's clean data that is produced by the from the data cleaning stage. Okay, and then the data is also already have label to that. Okay, and then next is on the model evaluation. You have to evaluate the output on the tested or the safeguard data set. So this is where you cross check lah, okay, whether your model that you produce is what we call in Malay is short sendiri, or it is true that it can solve the problem given to you. Okay, and once you are satisfied with the model evaluation, the results of it, then you can deploy and monitor. So up to this model evaluation stage, okay, you can see on the model deployment and model monitoring is where it is started to be deployed to the real world execution. And then this is where you can identify for the possible errors. Okay, so if you can see in this nine workflow of machine learning, there are 9 stages in here. Okay, these machine learning are the workflow are represented in the linear steps. Okay, so it's you can see it's very simple and it's very very systematic lah. Okay, one by one, step by step, and very simple. However, the truth is behind for the machine learnings to work, it is highly non-linear, because it requires several feedback loop. Okay, so the feedback loop that I mentioned is first is during the model training. Okay, so if during the model training you can see that there is something wrong with your model training, or maybe your result does not match with the criteria, ataupun your result does not it does not satisfy lah, the accuracy level may be too low, then you have to check back. Okay, this is the loop. You have to go back to your feature engineering, whether your features, like the feature selection, during the feature selection, it is Is it is it the features that you choose are correctly chosen? Is it the features that you choose really represented the problem that you want to solve? Okay, so you have to check back, okay, on the feature engineering. And there is also in the model evaluation and during the model monitoring also, there is the feedback loop. Okay, so if there is something happens during the model evaluation, you have to go, during the model monitoring, you have to go back to the model evaluation to check whether during the evaluation stages there is problem or not, or maybe it works only during the evaluation, however it doesn't works with this real world execution. So what are the problems that lies in between those and how you want to rectify those? So that is the problems that usually occurs during the machine learning stages. Okay, so SE for ML. So this, the need for the adjusting the software engineering practices in the recent era has been discussed. Okay, researchers have been discussing this starting from the hidden technical debt. Okay, so this is by Scully and the troubleshooting the integrative AI. But these researchers are only they already identifies what are the machine learning system architecture and requirements that need to be considered during the system design. Okay, they want to implement this during the system design. And then maybe what other problems between that hidden between the real world and the evaluation set. So these have been discussed by these researchers. Okay, and then there are some researchers also have been discussing on the impact of using the ML-based software, which have a risk on the safety and the risk concerns of the ISO standards. And over the last 5 years, industry have started to venture into the using ML in their softwares to automate, okay, in building the frameworks and environment to support the ML workflow and its experimental nature. As I mentioned, machine learning is ever so flexible, okay, and also and that is why then the industry identified machine learning as is still on the experimental. The maturity level is on the experimental level. Okay, and the ongoing research and surveys shows that the engineers are still struggling to operationalize and standardize the working processes. Right. So I will touch on the best practices with ML in software. So this has been shared by the Microsoft Research. Okay. So they have identified what are the best practices to implement the machine learning in the software engineering. First is to end-to-end pipeline support. Okay. As the ML components become mature and integrated into the larger software systems, so they feel the needs to integrate the ML development support into the traditional software development structure. But this is challenging because the differences in the characteristic of machine learning modules and also the traditional software components. Okay, so they come up with the pipeline support. So this pipeline support, they develop the pipeline support. They come up with the Azure ML for the Visual Studio Code and also Azure ML Studio to help their engineers to discover, digest, understand, and transform data, and then train and deploy and maintain models. So if you can go to this Azure ML for Studio Code and Azure ML Studio, this is actually more on the machine learning is made easy for these engineers actually, so that engineers can understand what lies behind the machine learning. Okay, and they can try to adopt and adapt the models into their system. All right, and second is the data availability, collection, cleaning, and management. Okay, so because machine learning, you have to collect, okay, whether the data is available or not, whether it is valid or not, okay, and then you have to collect, clean, and manage the data. So the first part of the processing in machine learning is tedious actually. So the industry feels that they need to reduce the time frame Okay, and they want to reuse the data. So what what they do is they try to blend the management tools with their machine learning frameworks to avoid the fragmentation of data and model management activities. So they can reuse the data for many times lah. So they can in reusing the data, what they did, okay, reusing the data by reusing the data with different models will produce different data versioning, different versions of the model. So so they need to, it requires and in order to update those data, it requires vigorous data versioning and also sharing techniques lah. So they want to implement, they are actually try to implementing this in Microsoft. Okay, keep on updating the data. Okay, they have a steady data set for the ML to be practiced. Okay, and then this data set will keep on updating with what kind of models that is suitable with this kind of data set. Okay, and then next is on the education and training. Engineers with the traditional software engineering backgrounds need to learn how to work alongside with the ML specialists. So this is what I'm trying to do. I know because I'm not sure because what I know, we as human, we are limited to the certain area of knowledge that Allah have given to us. So maybe my niche area is machine learning. So I'm not very I'm not very well known to the in the software engineering processes. I know a little bit here and there, and I believe that same goes to you. You know your areas very well, but the other areas is like, oh, I have heard this, and that, but the in-depth knowledge of that is not there lah. Okay, so it need to, so what Microsoft have tried to implement is the software engineers background need to learn on how to work alongside with the ML specialists and vice versa, so that they can learn on how to complement each other. And then the next is model debugging and interpretability. Okay, debug activities for the component that learn from data is not focusing on the programming bugs. Okay, but it also needs to focus on the inherent issues that arise from the model errors and uncertainty. Because when you work with machine learning, there are a new world of uncertainty in the model. So the engineers especially need to understand when and how the model fails and how to make the accurate predictions. Okay, so by learning to try and error on the machine learning algorithms and the optimization complex, the complex your data is, the bigger your system is, your machine learnings and the workflow will be complicated, and the optimization complex is even so lah. Okay, so the machine learning, the Microsoft proposed to use the more interpretable models to develop the visualization technique and make the black box model more interpretable. Machine learning, for example, you mentioned the neural networks or the fuzzy logic. Okay, on how, because machine learning is based on the mathematical expressions. Okay, so what they have is a lot of black box. Okay, black box model. So black box model which means that you do not know what happens there. You know that the output is there. So it is hard to figure out what happens in the black box. Okay, even as a data scientist or in the ones in the niche area, if you are already working with, for example, in one model, you are already into that area only. For example, if you already works with fuzzy logic or neural network. Okay, the process on discover on these black models also already take years to understand what happens inside. So this Microsoft understand this, and they want to make the black box models more interpretable so that the engineers would understand what happens and they can actually know what to how to solve the problems lah. So so this is how they try to do it. And then next is the model evaluation, and deployment. Okay, ML-centric software goes frequent revisions initiated by the model changes, parameter tuning, and data updates, and the combination of which has significant impact on the system performance. Okay, so they propose on the multiple metrics. Okay, and performing human-driven evaluation for the more sensitive data categories. Okay, so even in AI, whenever because the model is keep on evolving, as mentioned, due to the changes in the model, the parameter tuning, and the data updates. Okay, so I also believe in having the human intervention in the data model to validate the output, because to see whether the validity of the output. Okay, and this is due maybe for the more sensitive data categories lah. All right. And the conclusion of this discussion, okay, we already comes to the conclusion, is that the existing work certainly proves that the field of software engineering is fertile ground, which means there are lots of opportunities, okay, for the application of machine learning model. If you search out there for machine learning, for software engineering, there are lots of studies that have been done, that have been conducted on to study where to apply the machine learning in maybe in the stages of software engineering, in the life cycle of the software engineering. Okay, and it is clear that it is increased interest in the niche area of machine learning and the software engineering. The strength of the machine learning lies in the fact that they have sound mathematical and logical justifications. Okay, however, it does the power of ML method does not necessarily coming from the induction, but the proper formulation of the problems, how well you understand your problem, and from the crafting the representation to make the learning tractable, and you actually know what you want from the output from this problem, what kind of solution that you want to have. Okay, that is very important. In my experience, that is very important. Okay, and it is expected that this interest in applying machine learning in software engineering tasks will increase significantly, especially with the increased interest in the empirical software engineering. All right, so I think that's all for my sharing session today. So over to you, Luqman.
Okay, thank you, Dr. Hidayah, for the sharing. Now we will open the Q&A session. If anyone has any question or comment about the topic shared just now, you can ask your question.
Doctor, I just want to ask, because I realized data to have a successful data integration within an industry, why is there a need to have machine learning? Is it a must? And if the industry does not prepare, how can we make them at least they have the tendency to go do research for machine learning so that we have ability to integrate data within industry?
Okay, I try to answer Iza. What I believe, the industry are trying to right now currently, they are trying to adapt this technology of machine learning, the automation, okay, the using of AI and the automation in the industry. Companies like Alibaba and Microsoft, they have their research punya department, okay, to study on this, to experiment on this, and the effort, for example, the effort by the Microsoft itself shows that they want to support the engineers. That's why they are proposing they are producing the pipeline so that the engineers can study well, because they want to automate the integration of data itself. So that is tedious lah.
Yes, I understand. Thank you.
Am I answering your question?
Yes, yes, I understand. Thank you, thank you, thank you, Doctor.
Do we have any more questions? If there's no more question now, I would like to invite Ms. Nurhamizah to start her research progress presentation.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. My name is Nurhamizah binti Hamka, and currently my title for research is ontology-based approach for heterogeneous information integration. Okay. Okay. My background of study is actually yeah, I am focusing on transforming application and database integration, which is a very crucial part in successful digital transformation. Because currently, in the industry that I'm working, there are a requirement that they need real-time analysis of enterprise data to help assist them in making a business decision. So because back in referring to literature, enterprise are actually increasing their needs for data scientists to interpret what are the business value from the data that exists in the industry. So however, because of existing data that are not clean, or what should I say, there are diverse data being stored in spreadsheet, Excel, and also there are multiple type of database, which is not only Microsoft database, there are also Oracle database. So the integration of the data requires some mediator services in between to make the digital transformation a success. Okay, what currently my motivational problem is that from real perspective, there are application integration and data integration is actually need to work together, because referring to integrate application and data is require large investment, but there are like limited guideline for enterprise to have a successful automatic data integration. Referring to the what we call current situation in our government agency, for that allocated 70 million for my industry also, they do not want to have allocation for high allocation. So we need to do some research on how to have a successful digital transformation without very expensive cost. And what our research problem is that the reality is that collecting, integrating, and reconciling data from multiple heterogeneous data source is a major challenge. And not only that, data also come from different various source, and also they also have a multiple different format. So what I had identified is that there are insufficient research that incorporate application integration and data integration for a successful digital transformation. So my research is actually I'm trying to produce an ontology-based services for integrating the data and application within my organization. So the main research question is that how to integrate data from heterogeneous enterprise information system, because okay, what is enterprise information system? Within it represents human resource management system that have leave application, also accounting systems and such. So my first sub-research question is, what are the existing technique or method that used to integrate data from various applications? So, and my first objective is actually, I have from the existing technique, I have to design a conceptual framework for database integration, and I need to use it. I need to follow the principle of software engineering. So what is the deductive is might be the data integration method, and how to inquire the technique is through literature review or one or two industrial white papers. And second research question is, what are the technology that could support in automating information integration during real time? So I believe I follow what Dr. Says about machine learning, because I several researchers like Stonebreakers also proposed machine learning algorithm is one of the alternative if the industry want to do automated data integration. But I am currently still collecting literature review to support. Is it machine learning is one of the way, or we can incorporate it with ontology-based. So and the third one is that how to achieve optimal performance of data integration across application. So by this, the third objective is to implement the algorithm within ontology-based service to support automatic data integration in enterprise information system during production. I'm not yet thinking of the deductive and how to achieve that strategies. Okay, this is from several. This is from my literature review, because because data integration research have been actively involved during the 90s. So from this, I have identified several theoretical framework. Some of it are mostly for integrating in application integration. They are using service-oriented architecture. But apologies, because the article might quite very cannot be, the reference cannot be referred, so I need to search for the latest. And there are also researchers that start using semantic web framework to integrate data, and some of it are using a mediator. That means they are developing a mediator system that automate the data integration. And I also found that studies by Lee 2017, this has stated that there are needs of human in the loop for data integration, because human will validate and verify the data. Okay. This is what a problem statement that exists in my literature studies. So I'm referring to the PAN 2015, but in my industry is still is the problem still exists, and currently searching for the suitable way to integrate application and the data. Okay, my expected result is uh, actually because management need business decision, so might be a new interface dashboard system that implement ontology-based algorithm for integrated information and application in enterprise information system during production environment. So my significant of study is who will be benefit for this study is for corporate or government or industry for their business development or digital transformation information technology unit. And research contribution is might be I combining data integration methodology and application integration by applying software engineering principle. I need to further the study because my study I think too general. Okay, I think that's all.
Okay, thank you, Ms. Nurhamizah, for the presentation. Now, if anyone has any question or comments regarding the research presented just now, you may ask them.
Assalamualaikum Hamizah.
Aku salah doktor.
Okay, this is a very relevant topic, even though it is a it was initiated in, I think, very long time ago, and then many research been done in the 90s regarding data integration, like what Dr. Hisham discussed last week in his sharing session, also emphasized on data integration. Okay. My question is looking at the latest development of data integration and application integration work, what are common problems being highlighted by existing researchers?
Basically they have been highlighting the schema mostly on the schema of the words, the data, which is okay. What I found out is that for example, in some situation where in a human resource system, the table employee represent the user of the system, but in like accounting system, table user, they are using users and one is using employees table. So there are some they are highlighting the semantic heterogeneity of these two information. That is
Okay,
one. That is one.
Yeah. Let I refine my question. When you're looking at the existing solution proposed by existing researcher, what this is a common problems that they are focusing, right? Where the integration of the data. What are the common thing, or what are the trend in terms of the solution that they propose? What they propose currently, latest, like if we say latest 3 or 5 years, what actually the researcher proposed?
Yeah, if they are focusing on automating data integration, the trend is they are proposed to use machine learning algorithm. And I don't and actually I not yet study why machine learning is the sole so it's the best solution for automating. Because before machine learning, they are using APIs web service. So at current, Stormbreaker is one of the data scientists very well known data scientist that for making from the book Making Database Work, he also mentioned that machine learning is one of the best solution if want to have successful data integration. So, but at my point of view is still I need to do further study on why machine learning and uh, what are the algorithm in machine learning can support. That is the current trend, Dr. Dayang. Am I
Okay.
answering?
Yeah. You answer my question. So,
Still,
from my view is your 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 um your um your problems is big. You know,
yes,
you
I
need
know.
it is very big, and then there are many type of solution and many type of problems, and with the latest development of software development and integration, they might have a different technology that you need to support. Okay,
Yes,
this is a very big
broad.
and real problem. Okay, knowing that you are from industry, um, diversity will be there because you want to look at different technology, different different way of approaching it. Okay,
Yes,
because industry have different way of doing it. Okay,
yes,
when you look into the researcher point of view, like what you mentioned is researchers start looking at the machine learning, where you, because when you're talking about research is the thing that we still developing. It's not been finalized as the end product. Okay, so this is dilemma when I supervise industry-based researcher, where they want to look into the practicality of it. Okay, yeah, it's good because when you look into the latest the even though a normal researcher will appreciate, okay, machine learning is the best, but when we look into industry point of view, they're looking at the practicality of it. I know this is what happened when I supervise my industry student. Yeah, you need to balance this because industry is the point where we are solving now. You are in the industry are solving the problem now, and you are looking into the practicality of it. Okay, and then machine learning is something that will be used in industry in nearby future, might be another few years in certain it, the development of machine learning is like Dr. Hidayah mentioned just now is it's 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 very evolved from industry to industry. Like for example, if we're talking about industry that very critical, like uh, very safety critical. Okay, like this type of industry not going to apply machine learning directly. They might have different type of research in applying the machine learning. Okay, because they cannot reach the situation of safety, things like that in using machine learning. So my advice is you need to really balance it into the practicality of it and the research. But you need to bear in mind, research is something that you need to do and you need to looking forward. This will be possibly will be implemented in another near future. You need to consider that as well in your research. Okay.
yes,
So my advice is look into the latest development of problems, what other researchers doing. Look into the solution that they provide, and be open-minded to look into the machine learning. Might be that is the best solution, but that is not the sole solution. There are many other solutions. When we're talking about software engineering, machine learning is not the only solution. We have so many things to solve it. Might be not the problem is not because of machine learning, but it's because of the discipline of the engineer, the methodology that the engineer use, the strategy that the engineer use. So there are many things that we can tackle beside looking at machine learning itself. So I think what you need to do is you need to focus with the problems and then look at the possible solution and be open with the machine learning solution. Okay?
okay, doctor. Thank you for the suggestion.
Okay, so Mustaba has a question. Maybe you can ask.
Assalamualaikum. Yes. Do you hear me?
Yes, I'm hearing you, brother.
Okay. Oh, mashallah, very good. I have some questions regarding this machine learning, Okay, I'm not expert and I don't know about it, but what I learned that it explains, learns, predict, and improves the algorithm or whatever. Is it
Yes.
true? Okay.
Mm-mm.
In your research, you speak about data integration.
Mm.
Can you explain in detail about ontology-based services for data integration? What is ontology and how you want to integrate, and what is the uniqueness, of your research in industry? And second question, regarding in industry, due to data protection,
Yes.
industry, they will not reveal the data.
Yes.
So is it your research is limited to the industry, or will it be open source?
Okay, based on because we want to sharing the research outcome, so
Mhm.
we have to at least make it general so that actually others industry can also refer to this to the expected outcome in the near future, because industry will not easily share their data, and
Yes, I know, yes.
they also they need some solution based on because Malaysia also always say digital transformation, but the data or the line network is not ready. Sadly, the network is not ready, because in my industry plantation, they want the data like this, but
Yes.
gaining data from plantation in Malaysia, industry palm oil, where the internet is what we call that very slow as a snail. Yeah, it will. I don't know how can we do it, but maybe we might focus on the not for operational data. We just might focus on the end of the operational data. And so for if you say about ontology based, okay, because the data is in multiple database types. Some of it have in Microsoft, some of it have in Oracle, some of it have in other types like JSON and such. So what in the semantic web what ontology is like, it become like a data dictionary to calling this data, but first we need to set up the ontology base first. So instead of I develop the ontology, might be I search from previous researcher, if they already have tackled this ontology data integration, I'm just using their ontology, and we might do some algorithm on the existing ontology. So there are contribution in software engineering instead of on the data community.
Okay.
I don't know.
Yeah, but is your company allowed you to make it as an open source? Because I want to know whether your contribution will help us, as a researcher,
Yes.
or is it related to protected, from your industry?
Maybe like it will be a closed access, I think. Closed access.
Okay.
So how about Mujtaba research also closed access?
Yes,
or?
and it will be open.
Okay.
Yes, it is open source. That I want to contribute to the entire world.
Oh, so if you want to contribute, we cannot dedicated to our industry, right? So we make what?
Yes, I'm not.
General, right?
Yes, I will take it a practical way, but I will make it as an open source. That the contribution from me should be beneficial for all.
Understand.
But
Okay,
sincerely, I want to know about your research. It is I find it is not so clear, for me.
Yes.
Sorry to say.
It's very general.
It's very general,
Yes. Yes.
Yes,
Thank
yes,
you
yes.
for the feedback, brother.
Thank you. Yes, all the
Okay.
best. Thank you very much.
Miza, I know that you are in the early stage of your finding the proposal. Yeah, you are still like seeing, as you can see the light, but not that clear. I think after you present your proper proposal with feedback from the evaluator, inshallah you will have a clearer view of your research. But in again, regarding a Mujtaba issue on data just now,
Mm-mm.
okay, um, um, when we contribute in PhD work, we are expecting to contribute into the body of knowledge of software engineering.
Okay.
Okay, so if when you experimenting your approach, okay, it would be good if you can implement it using the available case study or the benchmark case study available being used by other software engineer. All right.
Alright.
I know that because Niza, you want to focus with looking at your problem that you also facing the same problem with your industry, right?
Mm.
With your company. You are very welcome to use uh, that approach that you propose or that you experiment with existing case study or benchmark case study, and then uh, at the end you can apply towards your uniqueness of the case study, because different case study have different uniqueness, different industry have different when we're talking about data integration, plantation might have different challenges compared to other industry. Okay, so these are the uniqueness that we want to highlight. Just that Niza, you cannot share your industry data in, but if somehow you can write to make it um, uh, anonymous, meaning that we not mention about in the industry, you're not going to mention in detail about certain things. Like if you're
Okay.
talking about project, you said project 1, project 2, project 3, and nobody can match uh, uh, which company that you're referring it to. And if your thesis still can be applicable, it still can be published as not restricted, meaning that you hide the information and then you not release the detail of it. Okay, this is one way to write a thesis with industry. But if somehow you when you write the thesis you cannot hide the the detail of it,
Mm.
then we need to go to the restricted version of it, especially the validation part where you use your data set. Okay, but somehow before you come to the data set, the final case study that you want to use, usually I would advise you to use an existing benchmark case study for you to experiment and for you to develop your methodology or framework or anything that you want to propose, so that you can publish your result and you can say to other researchers saying that, okay, I'm doing this is my idea on this. But when you want to apply it in your industry case study or in your company case study, then that is where the point you start to restrict your data. Okay, so just to bear in mind, even though you're doing industry work and it is restricted, you still need to publish. Then you also need to look into benchmark data or benchmark information that you can use and publish your work. Okay.
So doctor means that doctor suggests to find open source data or data validation, right, doctor?
Uh, at the beginning, when you proposing it and when you come up with the methodology, um, uh, or your approach, use benchmark data. Okay.
Okay.
Uh,
Alright.
unless if then at the end, because when you want to prove it to work in plantation, you will experiment it later, right?
Hmm.
So at that point where you really need to show, might be only the examiner will get access to the data for examination purposes, then that is at that point then you that and then the information you cannot publish because it is confidential, and only the examiner will read the information, and UTM will not publish your thesis as public. It will be confidential work. Okay, so there are a thesis that confidential for certain years. That, for example, wait until the company copyright or complete with the project, then they allowed the thesis to be publicly available, or we can have the thesis to be not available in public at all. We can have that option. All right. Okay. Thank
Yeah,
you.
Doctor, thank you very much, Doctor. Lukman, I think there's no question, right?
Okay. Anyone else? Any more question? Okay. Maybe Dr. Hidayah, a related topic.
But Dr. Hidayah, I need to study because I'm not familiar yet with machine learning. So thank you for sharing the session, Doctor.
Okay, I guess there's no more question.
Okay, Lukman, Nurhamizah, I just want to suggest that when you present later your expected result, you don't highlight for example, the system lah.
Okay.
You mentioned about a new interface dashboard system. So later when you haven't done your proposal defense, right?
Yes.
You haven't done. So because we do research, so do not highlight the dashboard system lah.
Alright.
That one is just about like a tool for you to prove a concept. And for your RQ, you go to your RQ, RO. For the RQ, you mentioned for the third one, how to achieve optimal performance. Do you measure performance when you use ontology?
No, Doctor.
So what actually you measure for ontology-based research?
Actually to the correctness, the correctness of the
Okay.
data.
So, because that one is the key lah for your when you present your proposal later. Okay, Nisa, all the best. Okay.
Thank you, Doctor. Thank you.
You're welcome. Okay.
Okay.
Thank you everyone for the questions and comments. And also thank you again Dr. Hidayah for the sharing and Ms. Nurhamizah for presenting her research progress. Here I also want to inform that our next colloquium will be held on Thursday next week. So I will send the invitation probably on Sunday next week or as soon as possible. Okay, so that's all. Now we are approaching the end of the colloquium for today. Thank you again everyone for joining today's colloquium. Have a great day, stay safe, and see you again in the upcoming colloquiums. Assalamualaikum, and you may leave the meeting now.
Thank you very much, Lukman. Thank you all.
Thank you, Doctor. Thank you all. Thank you, Lukman.
Thank you, Lukman.
Thank you.